This video serves as a memo for chat 2 or quiz 2 that we wrote. So I'll be trying to highlight most of the mistakes or common mistakes that I've seen going through the papers. So the mistakes that I'll be outlining, they're not entirely maybe your mistake, but they're mistakes that your classmates are doing, so you could learn from them. Okay, let's start. These are 5 questions, literally from just this one question. Use a Taylor polynomial expansion to deduct or deduce what I'm saying. Okay, yeah, to show us that is a good choice. So, and they also gave you some useful information here, so you don't need to do the whole Taylor approximation by yourself. They gave you here to make things easier for you. So so if it happens that you did the whole finding f prime and try to prove these, hopefully you ended up here, but you didn't really need to do that, and as a result there won't be any marks awarded for doing such, because we actually help you halfway, we kickstart you in a way. So okay, let's try to solve the problem. So f of x is equals to ln 1 plus x all over 5 minus x, like that, plus 3 all over 10 is equals to 0. So obviously we can solve this thing x directly. To find x, we have to approximate using lower order. So lower order here, they're trying to show you that at least keep it to pn of 2 quadratic, maybe Taylor series, right? So after all, it's an approximation, and then if we approximate this guy, we have a formula for him here. So starting when j is equals to 1, if j is equals to 1, this will be, so this top part will be squared to be 1 plus 1. So I'll get 2, then 2 squared is 1, and then x1 will be 1. Remember, j is 1, so there'll be a 1 denominator. Nothing's happening. So it's low order. I'll just do j is equals to 2. This is j. J is equals to 1. Now I'm going to j equals to 2. Okay, if j equals to 2, this guy will be 3. It will be 3. That means we'll get a negative 10. A negative 10. Okay, and that guy will be x power 2. Then that will be all over j. Now j is 2. Then we put 2. So that's alone this this guy same as this guy, right? Minus this guy, we're going to use this one also. The first one, when x is equals to 1, first term, you'll get 1 there on top. You got x, and below we'll get 1 factorial, right? So my mistake there, here j is starting at 0, so we'll have 0 there, become 1, and 0 factorial is also 1. That's a funny one, but yeah, it is. Okay, then 0 there will give us, we'll just get 1. Now what if is equals to 1? If it's equals to 1, then it become 1 plus x. If it's equals to 2, because ended on 2, I think on the other one, become x squared plus all over 2 factorial. There was 1 factorial here, so 2 factorial is the same as 2, isn't it? Now we notice that this guy was, he is represented by this guy. Okay, now we have to add, remember this thing, all of that was all over 5. Now we add 3 all over 10, right? From here you can actually solve for x because it's just a quadratic equation, I'd say. So solving for x here will be very easy because you're equating everything here to 0. So if you do that, you end up I won't do the whole analytic math in between here, but just your algebra. X squared is equals to 1 over 2, which then gives you x plus is equals to plus or minus 1 over root, all that and a root, right? Now we take these, we plug them to the function. So the goal is that remember when you're given a function that you can solve, which I think I mentioned that in class, you're supposed to do a polynomial, and from polynomial you can solve for a polynomial, and the answer that you get is a very good guess, close enough to the answer. So you can actually bound the answer that you get, hoping that now you have an interval to do your bisection method, because this is actually bisection. So we now have x where the function is 0 technically, because we equate it to 0. So now we can now put f of x. Now we're putting just square root of 0.5. we get something. Now what is f of x? Then f of x, we get square root of 0.5. Then we're just plugging in these things into this guy, right? And if you plug, there's a negative and a positive one from here. Remember, plug a positive one, you get 0.001. Plug a negative one, you get negative 0.04. Of which these numbers are good numbers. Remember, what bisection does, thinking, you have a function that does that, and you have a and b. For an intersection, or should I say the root to exist in the interval a and b, they should be in between here. There should be somewhere where you can put f of some number c such that you get 0. That's what root is, right? To guarantee that this thing passes 0 at some time, that means f of a must be negative, should have written more that way, and f of b must be positive. Technically, the right way of writing is saying f of a multiplied by f of b should give you a negative number. Should be negative number, let me say negative k, right? That shows that they have different signs. If this one is positive, it's negative, this one is positive, this is negative, it says that maybe, not maybe, surely in between those two intervals there should be a time where the graph cuts or has roots. So far, if we input our answers that we get a positive and negative number, that means yes, there exists a solution in between. And now we know that the solution exists, but which one is more close to the answer? And then we pick this one. The reason why we pick this one, this is 0.0013, of which is closer to 0 than this guy, right? So that means if you use this one, that's a good approximation. It's close enough to giving, if you use, this guy is close enough to giving you an output of 0. These things are not directly 0 because they're not really f of x. We didn't find this x from f of x. We got it from an approximation used Taylor series, of which is already, remember, f of x is some polynomial approximation plus some error. Obviously, we didn't account for this error. That's why the answer we get is not directly 0, but it's close enough. So if you got that one correct, you already scored yourself at least 5 marks in. So this one, again, 3 marks. So here, you're just doing bisection method, 3 alterations. Yeah, so there isn't much going on, but I want to show something, A, B, C, which will help us at least, I think so. So this is x1, this is x2, this is x3, this is x4, this is x5, right? 3 alteration, x5. This is alteration 1, alteration 2, alteration 3. C is a midpoint. Okay, I'm not going to do the table because it's just punching in and getting out numbers. But I want you to notice that it takes 3 alterations to get to x5. This guy here, right? So it's not going to look like it's useful for now, but yeah, they give us A and B. So if you put that in your calculator, you get your, let me just put them in, so that because you're gonna try if see if you got the correct answer. And x1 is already given as 1 all over root, and then x2 is 3 all over 4, and that's x2, by the way. X3 is 0.728, x4 is 0.717, x5 is 0.712, right? So yeah, we already find x5 of which you're interested in. So I don't have to do the whole table because I think I have a video where I'm doing bisection. I hope so. So here I'm just trying to show you how you answer, and I want to show you that what is x5 technically. You get it from 3 alteration. I think we'll see that on question D, why I was busy stressing on that. And now they say on question C, let me get it for you. Question C, let me copy it. Okay, for 1 marks, find I'm saying 1 marks, it's 1 mark. Okay, fine, this is not there. Determine f of x at 5, the function output when I put in 5. So we already know what 5 is, so it's just going to be f of x of 5. We already know what f of 5 is 0.712. From here I circled, then you put that on a calculator, you get 0.00214. Obviously I'm punching inside this function. Nah? Good. Okay, let's try to see what we did C. That means you're going to D. Okay, we almost finished. This was a very short test, so if you already passed, you already see where you are now. So estimate the error at the 5th output. Let me put it like that. Or error at x5. What did I say? 6. x5. So there's actually a good formula that says that it looks like this. And then a minus b minus a is better, but I'm going to put absolute anyway. All over 2n, right? This is our formula we're trying to use here. But what tricky is that this n is not directly this n. Should have actually used a different number. Let me call k here for the sake of this video. Why it's not? Remember here, or actually it's easy. They're trying to find the error at x5. Error, what was the error while I was here, right? So that is going to be where we started, b minus a. We already know b minus a. They gave us, didn't they? So it's going to be that was our b minus a. It was 3 over 2 minus square root of 1 over 2 all over 2. Now the question, what is this n? Okay, this n is number of alteration. When did we get x5? On which alteration or which row, if you want to think about it like that, of your bisection table? So we were at 3. You see, we were at 3. That's why I've been trying to highlight that alteration 3, that's where we get x is equals to, x5. That's what they were looking for here. Think about it. X5 n is equals to 3. X5, yeah, that's what I'm trying to highlight on. X5 n is equals to 3. That's why I'm putting 3 here, not exactly 5. Then if I plug that in a calculator, hopefully you should get something that looks like 0.00536, of which will be your error as the third alteration, of which will be your fifth output. Not directly fifth alteration, but it be your fifth x of try, if I should put it like that. Yes. Then let's look at E, what they wanted in E. Let me go copy. Also on E, let me copy the question, paste it here. Also the E, it's also 1 mark question. How many alterations? This one is also a mistake, a common one. 10 minus 10, you can put 1 for you. It looks like the normal thing. This one also, there is just a formula, it's just a plug and play. It's a very big long lean formula. It's a log formula, it depends. Other people use lean, other people use log, but let me just number of alterations. Technically, especially on the memo here, they're using number of alteration as m. That's why here they call this guy n here, because n is an x number, it's xn, right? So here for m, number of alteration, they use m. So that means here it will be m, here it will be n. I'm just going back here. M. Cool. So number of iteration, the formula they used here, I'm going to show you what they use here, and then in the next one I do that log one that you guys are used to see. So if I do all that and divide by lean 2, it's going to give me 28.7. and remember, these are number of, you can have a number of things being commas, so it has to be 29 alterations. So that marks the end of the test that you guys wrote, but obviously there is a log formula that you guys used to. So if you plugged in like this and got number of alteration, and you just put in b is becoming the same value that we're using there. B is, I think it was 3/2, while A was 1/2. Then the error is that guy, what you said is that guy, then you still get the same answer. So I think hopefully the way it looks, most people did better than the first tutorial test, but I just want to mark this thing here, that this m and n are not the same thing. This n here is the number of iteration. This guy here is the number of x you are on. As in here, this is x1, this is x2, this is x3, this is x4, this is x5. And then x5 is in n is equals to 3. That's why this does that. So thank you for watching.